Hello. Today, we will discuss yield strength. Yield strength is one of the various definitions that come from the stress-strain diagram. We will explain the definitions of elastic region, plastic region, true elastic limit, proportional limit, elastic limit, yield strength, and X% offset yield strength that appear on the stress-strain diagram. First, let's review stress and strain. Stress represents the force per unit area and can be expressed as shown in the equation on the right. Strain refers to the ratio of the elongated length to the original length when stress is applied, as shown in the equation on the right. For more details, please refer to Chapter 3.1.1. The stress-strain diagram illustrates the relationship between stress and strain. As mentioned earlier, various definitions appear on the diagram, including elastic region, plastic region, true elastic limit, proportional limit, elastic limit, yield strength, and X% offset yield strength. We will now explain each of these. First, the elastic region. This area refers to the region where the material can return to its original state when stress is applied and then removed. The plastic region, unlike the elastic region, refers to the area where permanent deformation occurs when stress is removed. Next is the true elastic limit, represented by point 1 on the graph. The true elastic limit signifies the lowest stress at which dislocations begin to appear. The proportional limit, represented by point 2 on the graph, denotes the highest stress in the area where stress and strain are proportional to each other. Next, we come to the topic of yield strength, also known as the elastic limit. It corresponds to point 3 on the graph. Yield strength marks the point at which the material transitions from the elastic region to the plastic region. If stress higher than this point is applied and then removed, permanent deformation of the material occurs. Finally, X% offset yield strength, represented by point 4 on the graph. Because measuring yield strength precisely is challenging, X% offset yield strength is defined based on the plastic strain that occurs when stress is removed. It is defined as the point where a line with the slope of Young's modulus intersects the stress-strain graph after passing through X% strain. In superconductors, yield strength with a 0.2% offset is typically measured. The graph and table on the right show the results of measuring the stress-strain curve of Hastelloy C276. By comparing these definitions with the graph and examining the actual values, you can get a better understanding. In summary, the stress-strain diagram shows how stress and strain relate to each other. The true elastic limit is the smallest stress level where dislocations start. The proportional limit is the highest stress where stress and strain are still proportional. The elastic limit, also known as yield strength, is where the material shifts from elastic to plastic deformation. The X% offset yield strength is the stress value that corresponds to X% plastic strain. That concludes our presentation on yield strength. Thank you for watching.